Welcome to Digestion and Physiology Series 3, Part 2, Sources of Fat. In Part 1 of this series, we talked about the process of fat digestion. In Part 2, we talk about sources of fat. Fat is an energy source, but where can you source these fats? All feeds have some sort of fat content, even grains. In fact, all feeds have a fat content, an ash content, a water content, and a carbohydrate content. Grasses have reasonable levels of fat, it's just not in the form you are used to seeing. Microbes produce volatile fatty acids in the hindgut, which we talked about in the previous series. You can also add oils to the diet, which is a great source of energy if you need to add an extra 10 to 20 megajoules. Adding a cup of oil to the diet can cause a reasonable increase in energy in a small, concentrated amount. As previously stated, it doesn't cause an insulin response, it's cool energy. It can improve digestion because fats take a while to digest. When the body detects the presence of fats in the diet, it releases hormones, which slows down the digestive tract, allowing more digestion to occur. It is important to be aware of the omega-3 and omega-6 ratios, with the ideal being a slightly higher level of omega-3 in the oil than omega-6, about 2 to 1. To elaborate more on the importance of specific oil types in the diet of horses, there are 3 groups of fats that need to be considered. They are omega-3s, most commonly known as alpha-linolenic acids, or ALA, omega-6s, which is primarily linoleic acid, or usually abbreviated as LA, and omega-9s, with the most common one being oleic acid. Omega-9 is necessary in the diet, but not in huge amounts, and can be created in the body of the horse. So there is not much focus put on omega-9, but there is certainly much focus placed on omega-3 and omega-6 oils. There has been a lot of research in recent times about the amount of omega-3 and omega-6 required in the diet. Both are considered as essential fatty acids because the body, similar to essential amino acids, cannot make them, so they need to be added to the diet daily. Omega-3s can be converted in the body into one of 2 specific members of the omega-3 family, EPA or DHA, with both having a positive effect on the horse's health. Both omega-3 and omega-6 oils are needed to produce a very important hormone called prostaglandin. The difference, though, is that omega-3s produce a type of prostaglandin that results in a reduced internal inflammatory response, reduced incidence of osteoarthritis, reduced allergic hyperactivity, or in other words, the immune system isn't overactive, and a reduced incidence of exercise-induced pulmonary hemorrhaging, which is bleeding on the lungs. Omega-6 produces prostaglandin, but a different type to omega-3. The prostaglandin produced causes an increased internal inflammatory response, an increase in osteoarthritis occurring, an increase in allergic hyperactivity, and an increase in the incidence of exercise-induced pulmonary hemorrhaging. In essence, they end up producing the opposite effects of each other. It is important to have a good balance between omega-3 and omega-6 oils, as omega-6 oils produce certain hormones and steroids essential for normal, healthy body function in the horse. Knowing this, while a balance is needed, obviously it's more beneficial to have higher levels of omega-3 than omega-6. But what is the best ratio? Like anything, when you look at it from a physiological perspective, more is not necessarily better. There is a point where you achieve the maximum benefit, after which you start to see a decrease in the response by adding more and potentially having a detrimental effect. For example, continually including omega-3 oils in the diet without supplying a source of omega-6 has been shown to suppress the immune system in animals. It was originally thought that about 4 to 7 parts omega-3 to 1 part omega-6 was the best level, as that matched the levels found in many grasses. Research in recent times, though, has suggested that maybe it's closer to 2 or 3 parts omega-3 to 1 part omega-6, possibly even getting towards 1 to 1, around neutral. It's still unsure exactly what is the base optimal level, with a lot more research needed. We've mentioned previously that fats and oils have about 2.5 to 3 times more energy than carbohydrates. Let's now compare the energy density of fats and oils in some common feeds. Hay, for example, and depending on the type of hay, has an average energy density of around 9 megajoules of digestible energy per kilo, without any moisture in it. Corn, being a grain, has a greater energy density due to its high level of sugars and starch. Corn has about 15 megajoules of digestible energy per kilo of dry matter. Oats, with less starch and sugars compared to corn and more fiber, has an energy density of about 12 megajoules of digestible energy per kilo of dry matter. Oils and fats have an energy density of about 35 megajoules per litre. This means oils and fats have about 3 times the amount of energy of oats, 2.5 or a bit more compared to corn, and about 4 times the amount of energy in hay. But as mentioned in the previous series, hay is high in structural carbohydrates. It will be digested through microbial fermentation, producing volatile fatty acids, which have an energy density of about 35 megajoules of digestible energy per litre. So the energy density of hay potentially is a lot higher than the figure of 9 megajoules per kilo of dry matter suggests. What benefits are there from feeding oil? It has a much higher energy density than other feeds. There is no insulin response as it travels through the blood as fat instead of glucose. It is quite readily digested in the small intestine and can improve digestion of other feeds because of the physiological response of slowing down the digestive system. Fats and oils can actually help preserve energy in performance horses, as you can save a lot of the energy stored in the muscles as glycogen, which is needed for galloping, by having a performance horse utilize this more energy-dense, cool energy at times when they're not performing. Research has shown that you can reduce sweat by as much as 15% by feeding a good level of oil. At times, when it's very hot, with high humidity, a performance horse can reduce sweat loss, reducing the risk of dehydration and loss of electrolytes, which is obviously going to benefit the horse. It's important to only include fats and oils into the diet in small amounts because it's very high in energy. Unfortunately, like all good things, there's a bad side. It's like having your chocolate cake, but it comes with the calories. Oils can cause an inflammatory response. If you have very high levels of omega-6, it's going to negatively impact on the immune system, which can lead to poor health and, as a result, underperformance. You may not see it as an outward display of poor health, but internally your horse just cannot perform at its best. Too much oil can impact on hindgut fermentation. As previously stated, hindgut fermentation is key to the health and performance of the horse. If you have too much fat and oil in there, you run the risk of coating the feed and the microbes in the hindgut with this oil and fat, which is going to impact on the ability of the microbes to break down the feed. They can't release their enzymes, and the enzymes they can release cannot penetrate the oil to break down the fiber. As a result, the microbes die because they are not eating, so you get poor digestion. These microbes contain endotoxins, and your horse can get sick from them. It's been shown that you can feed up to 20% of the diet as fats and oils, but the maximum recommended level is about 10% of the total diet. It's good practice to set the level between 5 and 10% of the total diet when formulating rations. So, your take-home points are: There are many different sources of fats and oils. Some are natural and found in all different feeds. Some need to be added separately to the diet. There are two main essential fatty acids, omega-3 and omega-6. Both produce the hormone prostaglandin, but omega-3 oils produce an anti-inflammatory version of the hormone, whereas omega-6 is quite inflammatory. The ideal ratio between omega-3 and omega-6 is still unsure. A lot more research needs to be done, but at this point it seems to be around the ratio of 2 to 3 omega-3 to 1 part omega-6. Fats and oils have about 2.5 to 3 times the energy of carbohydrates. There are many benefits from feeding fats and oils to horses, but it's important to remember there are some limitations too. Thank you for watching Equine Digestion and Physiology Series 3, Part 2. If you like what you saw, please give us a thumbs up and share it with your friends. Connect to our website, our EqNC Facebook page and Instagram so as not to miss our next series.